Assalamualaikum to all my fellow panel. My name is Nurul Ain Kamila binti Abdul Nasir. My metric number is AN18040. My supervisor name is TS Muhammad Lufi bin Ahmad Jani, and my co-supervisor name is DC Helmi bin Kosnim. Today, I want to present the topic that I propose for final year project, which is the use of reclaimed asphalt pavement (RAP) miling waste as replacement materials of coarse aggregate in concrete mixture. First of all, I will explain about the introduction, which is the background of this study. As we know, the concrete is still one of the most popular and usually used these materials in the construction industry, as it has a high strength and flexibility. The concrete is made up of a mixture of fine aggregate, coarse aggregate, cement, sand and water. Other than that, by recycling and reusing the waste material that produced from roads, industries and agriculture is not only produce economic profits, however, it also be environmentally friendly. Nowadays, reclaimed asphalt pavement have become a global trend, as the road pavement is usually need to have a maintenance when road damage occur. Recycled asphalt in road pavement is mainly found from remove all asphalt surfaces intended for of landfill that is crushed to size and will be used as aggregate. Thus, as the benefits, the use of road pavement miling waste can save cost and time, as these materials already have from the demolition waste at the construction site. Next, we go for the objective for this study. The first objective is to investigate the mechanical properties of the road pavement miling waste in concrete. This objective is to know whether the properties of road pavement miling waste can be a better aggregate comparing the normal aggregate that usually used. For the second objective is to determine the optimum percentage of road pavement miling waste as replaced in concrete. This is to know the best percentage that's suitable to use as the replace the existing aggregate that used in the concrete mixture. The problem statement for this study, which is the demand for aggregate for use in concrete production may have adverse environmental and ecological effects. The use of recycle, which is reclaimed asphalt instead of gravel aggregate, will help to mitigate these effects. It also has the potential to reduce the amount of recycled asphalt obtained from road resurfacing that will otherwise be disposed of in landfills. Moreover, Malaysia is one of the countries that has increased total expenditure for road maintenance, as they need to maintain a safe, efficient and economical roadway system. This will lead to significant increase of a demand to restore the existing pavement. The compressive strength of the concrete decrease as the amount of reclaimed asphalt pavement used to replace natural aggregate increase. Therefore, this study will aim to investigate the strength of reclaimed asphalt pavement (RAP) as a replacement for coarse aggregate in the concrete mixture. The scope for this study, which it will use the miling waste of crushed pavement as the material in the concrete mixture. The pavement miling waste will collect at the Sime Darby, Pago, and the research will conduct in the concrete made laboratory at University Tun Hussein On, Malaysia, UTHM Pago. The size of each sample cube is we use 100 mm. This research will analyze the strength of the mixing miling waste in concrete after 28 days. The test will be carried out for this research is sieve analysis, density, water absorption, slump test, and compression test. Next, we go for the chapter 2, which is literature review. In this table, it shows the summary of literature review. The first author, which is Al-Mufti, it is published on 2017. The material that the author used is the recycled asphalt aggregate, water, aggregate, and cement. The properties, which is the concretes made with recycled asphalt have a lower strength than concretes made with the existing aggregate. The method the author used is the compressive strength. For the second author, which is Alan Seri, it is published on 2021. The material used is cubes concrete mix aggregate and recycled aggregate. The properties is the compressive concrete strength of natural aggregate concrete cubes was higher than that of a recycled aggregate concrete from the text. The method used is the compressive strength and workability. For the third author, which is Mansourian, which is published on 2018, the material used is coarse and fine reclaimed asphalt pavement, Portland cement, reclaimed asphalt pavement aggregate. The properties is the mechanical and environmental performance of concrete containing 100% of recycled RAP aggregates, and finding this concrete composition had a lower modulus of elasticity and compressive strength while it is having a higher flexural strength. The method used is flexural strength test and compressive strength. For the last author, which is Ajabi, it is published on 2018. The material used is aggregate of the same size, cement of the same strength, water content, and water or cement ratio. The properties used is the compressive strength is the most important mechanical property of concrete. Aggregate quality, cement strength, water content, and water or cement ratio are some of the parameters that determine the concrete strength. This is what the author of Ajabi say. The method used is compressive strength test. Next, we proceed to the chapter 3, which is methodology. The first thing I want to explain is the flow chart of the methodology. This figure is show the flow chart. The first is to determine the title for the study, which is we need to discuss with the supervisor in the choosing of the title for this topic. Then, the literature review, find the several reference materials that related to the title of the study that has been searched. Next, it is laboratory studies. It is perform the experiments in the laboratory to obtain the results for the study. Then, discussion and analysis, which is we need to analyze data that have been obtained from the laboratory test, then make an expectation from the tests that have been made. And the last is writing a study report. It is provide a complete report on the result of the study that has been conducted. So from the flowchart of the methodology, it is explained about the detail of the project that have need to do for this study. Next, for the methodology, this table it shows the concrete needs design amount of material that used based on DOE method. This overall calculation is based on the DOE method. This table is calculate the amount of cement, water, fine aggregate and coarse aggregate that will be used for this test. The coarse aggregate that I decide to use is 20 millimeter. The last aid for the methodology, which is experimental detail. The test used for this project, which is sieve analysis test, slump test, water absorption and density test, and the last one is compression test. The standard that used for this test, which is British standard. The test for the water absorption, density and compression, it used for 7 and 38 days. The size of cube that used is 100 millimeter cube. This test is need to know the strength of the concrete cube between the reclaimed asphalt pavement concrete and the normal concrete cube. Next, we go to the Gantt chart. For the final year project 1, this figure is show the planning chart, which is start from week 1 until week 14. It have 12 activities that I have been planning. The status shows the planning and actual. This Gantt chart will help me a lot in a punctual, as I need to follow the week to finish my activity that I have been planning. This figure shows the Gantt chart, the planning chart for the final year project 2. This is the activity that I have planned to do for the next SEM for the final year project 2. For the expected result in this study, which is at the end of this study, the mechanical properties of concretes that content of recycled asphalt pavement will produce the lower workability than concretes are made with normal aggregates. Then, the concrete that has a road pavement milling waste has a lower compressive strength than the normal concrete. For a conclusion for this project, in a nutshell, there are many benefits in reuse of the road pavement milling waste, as it can save our lands from pollute. Aside from that, using reclaimed asphalt pavement in concrete supports the zero waste movement and the green industrial agenda, as it can reduce the trash in landfills while also producing green concrete without the use of non-environmentally friendly Portland cement. As a result, this research can be the right option for reducing waste and lowering the environmental effect.